Hi, hello everyone. Welcome back to Dr. Zahir Math. In this video, we will explore an important topic in differential equations, homogeneous linear equations with constant coefficients. This topic is widely used in engineering and plays a crucial role in solving real-world problems involving dynamic systems. So what is homogeneous linear differential equation? So a linear differential equation with constant coefficients, which is of the form an d power n y divided by dx power n plus a n minus 1 d power n minus y divided by dx power n minus 1 plus so on plus a1 dy by dx plus a naught y equal to 0. What about a naught, a1, a2, all these things? They are all constants. Okay, right. The term homogeneous means the right hand side of the equation is 0. If this is 0, then it is homogeneous. These equations are fundamental in understanding systems that exhibit exponential growth, which you already studied, okay? Exponential growth, oscillations, right? Mechanical guys, you know what is oscillations, right? And stability, right? So in where we are going to apply this in engineering, homogeneous linear differential equations with constant coefficients appear in many branches of engineering. For example, let's say in electrical engineering, it is used in circuit analysis to determine the voltage and the current behavior over time. So if you see mechanical engineering, it's used in modeling vibrations in mechanical structures such as bridges and buildings. In control systems, it's also a part of engineering. Electrical engineering plays a key role in designing stable and efficient, stable and efficient control systems in robotics and automations. So like this, these are the few applications for the second homogeneous linear equations with constant coefficients. Okay, right. So in this video, we'll derive solution to these equations and see how characteristic equations helps us to find the behavior of different systems. Stay tuned and don't forget to like, comment and subscribe to Dr. Zahir Math for more engineering mathematics videos. Okay, right. So in this video, we are going to talk about only second order differential equations. What do you mean by second order differential equations? We are going to start only d square y by dx square. Maximum is this one. Right. So before going to this one, I just wanted to say that about complementary functions. So actually this general solution consists of, usually the general solution consists of y is equal to sum of yc plus yp. What is yc? Yc is complementary solution. Yc is what? Complementary solution. Yc is the complementary solution and yp is called particular solution. This particular solution normally deals with the right hand side objects. But here right hand side is 0. So therefore automatically y becomes yc plus 0. So y becomes your complementary solution. Okay, right. So to find the complementary solutions, we are going to do something. What is that? For y double dash, you have to put m square. Y dash, you are going to put m. And y, you are going to put 1. Y triple dash is equal to m cube. Okay, right. So if you put like this, the equation will be changed into called auxiliary equations. Okay, in terms of m. Okay. So now we are going to solve second order differential equations. Okay. So you will get equation in m square like this. So once you get an m square, you go to the calculator, mod 5 and then 3. So when you use mod 5, 3, we will get 3 chances. It may be first equal roots, or you can say in the class first I said unequal roots. Okay, right. And the second one we call it as equal roots. Okay. And the third one we get complex roots. Right. If you get unequal roots, your complementary solution yc is equal to c1 e power m1x plus c2 e to the power of m2x. If you get equal roots, complementary solution is c1 plus c2x e power mx. If you get complex roots, which is of the model alpha plus I beta and alpha minus I beta. Alpha means your real part. Okay. And the imaginary part you have to take positive. Positive imaginary parts. Positive imaginary part. Okay, right. So which is given by yc equals e power alpha x bracket open C1 cosine beta x plus C2 sine beta x. Where is alpha? This one is alpha, which you are getting the real part. Okay. And this beta is going to become what? Imaginary part. Imaginary part means suppose you get 1 plus I, 1 minus I in the calculator. What is your real part? Real part is 1. What is your imaginary part? Imaginary part is plus 1, which is beta is positive. Okay, right. So these rules you have to remember. Unequal roots, equal roots, you have to remember. Unequal roots. So what do you mean by M1, M2, which you get in the calculator? What is M, which you get in the calculator? What about alpha, beta, which you get in the calculator? Right? Yes. Now let's go to the first question. The first question is question number 3. Question number 3. Find the general solution. Find the general solution. General solution means y of the given second order differential equation. Of the given second order differential equation. So y double dash minus y dash minus 6y equal to 0. Let me take this as question number 3. So I put a line. Next question is number 5. Find the general solution. Y double dash plus 8y dash plus 16y equal to 0. This is 8. Okay. This is the next question. And the next question is question number 11, which is y double dash minus 4y dash plus 5y equal to 0. Right. And the next question is question number 15. Y triple dash minus 4y double dash minus 5y dash is equal to 0. This is the next question. Okay. First we solve these questions. Right. So let's go to the solution. Right. So I told you for y double dash you are going to put what? M square. For y dash you are going to put what? M. For y is equal to 1. Y double dash you are going to put m square. Y dash is equal to m and y is equal to 1. Y double dash you are going to put m square and y dash you are going to put m and y is equal to 1. Y triple dash you are going to put m cube. Y double dash is m square and y dash is equal to m and y is equal to 1. Right. Now let's start this one. So you will get m square minus, sorry, let me change another color. Right. So you get m square minus m minus 6 equal to 0. Right. Because y double dash is what? M square. Y dash is what? M. And y is what? 1. If I put in the calculator, I'll get m is equal to 3 and minus 2. I think so. Let me check also better. I'm guessing in the mind. Right. Mode, that is equations number 5 and then plus number 3. Okay. Right. So 1 minus 1 and minus 6. So you get 3 and minus 2. Yes. Right. So this is equal to, this is unequal roots. If it is unequals, y equals c1 e power m1x plus c2 e power m2x. So what's your solution? Y equals c1 e power 3x, okay, plus c2 e power minus 2x. Can I change this and that side? Yes, you can change any one. First one you can write minus 2x. Second one you can write 3x. No problem. Let's go to the next question. Next question, we are writing m square plus 8m plus 16 equal to 0. So let me go to the calculator again. 1, 8 and then 16 equal to 0. Right, minus 4, minus 4. It is 2 times. So m is equal to minus 4 comma minus 4. Because I am getting x equals. It means repeated roots. Keep in your mind. So y equals c1 plus c2x e power mx. So y equals c1 plus c2x e power minus 4x. So this is your second solution. Let's go to the third solution. M square minus 4m plus 5 equal to 0. M square minus 4m minus 5 equal to 0. So let me go to the calculator. Okay, m is 1, m square 1 minus 4 and then 5. So I get the answer 2 plus I, 2 minus I. So m is equal to 2 plus I, m is equal to 2 minus I. m is equal to 2 plus I, m is equal to 2 minus I. Alpha is equal to real part, which is equal to 2. Beta is equal to positive imaginary part, which is equal to plus 1. Okay, right. So y equals e power alpha x c1 cos beta x plus c2 sin beta x, which is y equals e power 2x bracket open c1 cosine x plus c2 sin x. c1 cosine x plus what? c2 sin x. So this is your next answer. Let's go to the next question. The next question is you have y triple dash, right? So the equation will be m cube minus 4m square minus 5m equal to 0, right? So for this one you go to the mode because it's power 3. So equation 5, mode 5, and then you are going to number 4. So if you press number 4, you will get A is 1, B is minus 4, C is minus 5, and there is no constant, put D is equal to 0. So you get M is equal to 5, you get minus 1, and you get 0. Okay. So what happens now? You will get the answer y equals c1 e power m1 x plus c2 e power m2 x plus c3 e power m3 x. So therefore y is equal to c1 e power m1 5x plus c2 e power m2 x minus x plus c3 e power 0x. So this is equal to y is equal to c1 e power 5x plus c2 e power minus x, e power 0x is what? 1. So plus c3. So this is going to be your general solution. So everywhere you have to write yc, but I told you in this general solution y is yc plus yp. The right hand side you see all are zeros. Can you see that? So right hand side all are zeros. If all are zeros, yp is equal to 0. So y becomes yc. So you can write the complementary solution as directly y equals. No problem. Right? So it's clear. It's very easy. Okay. So this is find the general solution of the given second order differential equation. Let's go to the next equation. The next question, sorry. The next question is solve the initial value problem. Question number 33. Solve the initial value problem. Solve the initial value problem. Okay. The question is d square y by dt square minus 4 dy by dt minus 5y equal to 0. Y of 1 is equal to 0. Y dash of 1 is equal to 2. Right. So this is also homogeneous linear equation, right? Because right hand side is 0. So let's go to the solution. So which is m square minus 4m minus 5 equal to 0. Look here, the equation is directly given y double dash. We don't know y is depending on x or y is depending on t. Without knowing, we are keeping as x as a dependent variable, right? So directly we are taking, right? Yes, okay. Y, sorry, not dependent, it's an independent variable, right? So x is, but here it's very clearly given, it's t. So therefore, when you're writing the solution, you should be very careful. You should write in terms of t. So let me go to the equation, right? M square 1 minus 4 minus 5. So you get the answer 5 and minus 1. So you get m is equal to 5 and minus 1. Right. So what will be your solution? This is unequal roots, right? When it's unequal, y is equal to c1 e power m1x plus c2 e power m2x. So y is equal to c1 e power 5x plus c2 e power minus x. Okay, right. Now this is actually general solution, but in this there is some more things are there. You have to use this initial conditions. Why we are going to use? We are going to find the c1 and c2. So we have two constants. We need to find two constants. At least we need two conditions. What is the first condition? Y of 1 equal to 0. It means y equal to 0 and t is equal to 1. See, again I made a mistake. You shouldn't put x. It is t. Because The independent variable is here, it is t. So minus t. Right. So the next condition is y dash is equal to 0 when t is equal to 1. So y of 0 directly I can substitute now. But y dash of 0 I cannot substitute now because I want the derivative. So what I'm going to do, I'm going to take the derivative of this equation. So I am going to take the derivative. Why I need the derivative of this one? Because I want to put the second condition. So y dash is equal to c1 e power 5t. E power 5t derivative is e power 5t times 5 plus c2 e power minus t times derivative is what? Minus 1. So y dash is equal to c1 e power 5t times 5 plus c2 e power minus t times minus 1. So keep this as second equation. So I'll call this as equation number 1 and I call this as equation number 2. So I'm going to put the first condition. What is my first condition? Y of 1 is equal to 0. So it means this is your equation. Equation 1 implies y equal to what? 0. And t equal to what? 1. C e power 5 plus c2 e power minus 1. So let me write this equation in a different model. Same, but I'm writing first equation variables. E power 5, this I'm going to write. E power 5 is a constant. E is a constant. E power 5 is a constant. So e power 5 c1 and then plus e power minus 1 c2 is equal to 0. Right. Let me put the second condition. Y dash of 1 is equal to 2. Am I right? Let me check. Y dash of 1 is equal to 2. So it means equation 2 implies y dash of 1 is equal to 2. So I'm going to put in this equation. So c1 e power 5 times 5 because t is 1 plus c2 e power minus 1 times minus 1 which is equal to. So I'm going to write in a different model. Just listen carefully. Right hand side is 2. Okay. And the left hand side I take this constant in the front. 5 e power 5 c1 and then minus e power minus 1 c2 equal to 0. So this is my equation. So now I'm going to the calculator. Okay, right? Mode 5 and then 1. So let me go to the calculator. Mode 5 and then 1. Right. So when I go to calculator 5 1, what happens? You need to put this equation here. Right. So e power 5, you need to put the first is alpha e power 5. Okay, close the brackets and then press equal. The next is e power minus 1. Alpha e power minus 1. Close the bracket, press equal sign. The next is 0. Press equal. Next, when you come to next one, 5 alpha e power 5. Okay, close the brackets. Yes. And then press equal. Next is minus e power minus 1. Minus alpha e power minus 1. Close the brackets and then press equal. The next is 2 equal. Press equal again. So in the calculator I am getting C1 is equal to 2.24. C1 is equal to 2.24 10 to the power of minus 3. And I get C2 is negative 0.906. So this is actually 3 times you go 1, 2, 3. 3 times we go 0.002. 0.002. And this is negative 0.906. This is your C1 and this is your C2. Okay, right. 224 also you can put, no problem. Just 22 is enough. 002, right. So now we need to write the solution. This is your solution 1. What is your solution? Y is equal to C1 e power 5t plus C2 e power minus t. So this equals y equals your C1, which just now we got 0.002 e power 5t and C2 is negative 0.906 e power minus t. So this is the solution of this differential equation. Right? Yes, let's go to the next question. Next question, we have Solution is given and you're going to find the differential equation. What is that? Solution is given and you're going to find what? The differential equation. Solution given and you're going to find the differential equations. Okay, right. So let's go to the next question. Okay, right. So find a homogeneous linear differential equation. Question number 53. Okay, first I'll write the question. Find a homogeneous linear differential equation with constant coefficients okay, and whose general solution is given. Right. So how many questions we have? We have two questions. Question number 53 and question number 55. So question number 53. Right. Y equals C1 e power x plus C2 e power minus 5x, not minus, plus. Okay, plus. Next question is question number 55. Question number 55. Y equals C1 plus C2 e power 2x. Okay, right. So let's start the solution. So this is of the model y equals C1 e power m1x plus C2 e power m2x. So what's your m1? Which is 1. What's your m2? Which is equal to 5. Right. So let me remove m1, m2. We call it as m. So m minus 1, this is m minus 5 equal to 0. Here if it is plus, here minus. If it is plus, minus. If it is minus, it is plus. So slowly you multiply m into m, m square, m into 5 minus 5m, and this is minus 1m, and this is plus 5 equal to 0. So this is equal to what? M square minus 6m plus 5 equal to 0. So one more step I want to write without forget one step, which is same color I'll use. M square minus 6m plus 5. I'm going to write 5 times 1 equal to 0. All the time you write 1 as a constant, 0. Now keep like this. I will come back to you later. How to write the differential equation. Because the question is what? Find the differential equation. Still I did not write the differential equation. This is called auxiliary equation. M, right? Auxiliary equation means equation in a dummy variable, right? Now let's go to this equation. This is of the model y equals C1 e power m1x plus C2 e power m2x. Of course m1 is equal to 0 and m2 is equal to what? 2, right? m2 is equal to what? 2, right? So this is m minus 0 and m minus 2 equal to 0. Usually we don't write m minus 0. So m into m minus 2, 0. So m square minus 2m equal to 0. Is there any constant here? No. So if there is a constant, then you write 1. I'll tell you why. So before starting this equation, I told you to solve the differential equations of second order with constant coefficients. I said put y double dash is equal to m square. Y dash is equal to m. And y is equal to 1, I said. So this is what you should remember. So what happened to the differential equation? Y double dash, because it's m square, right? So this is y double dash minus 6 y dash plus 5. This 1 is nothing but what? Y equal to 0. Why, teacher? Why you are writing? Because it's an operator, differential operator. Keep in your mind. And here what will be your equation? Your equation will be here y double dash minus, there is m only, so it is y dash equal to 0. Okay, right. So this finishes your exercise. Am I right? Yes. So this finishes your exercise. What is the number? Which is 4 points. Let me check once again. Which is 4.3. Which is 4.3 is finished. Okay, right. So please work very hard. Okay, all the questions you practice very well, right? Thank you for watching. I will upload these notes in the description box as well as in the first comment of this video. Thank you so much. Have a good day. Take care. Bye bye.